Okay, well, this is the last assignment. It's applications of determinants. So the applications are Cramer's rule, which is a way of basically solving linear equations. And you take the ratio of determinants. And I can remember how to do that while I'm thinking about it. Okay, I've looked at it. You can also do the equation of lines in a plane using determinants. So anyway, we'll figure that one out. It's been a while since I've done these. Okay, problem number 1. Use Cramer's rule to solve, if possible, the system of equations. So we've done 2 ways so far, 2 different ways compared to what we've learned in algebra. One was to use an augmented matrix to solve for the unknowns. The second way was to find the inverse of the coefficient matrix and then multiply the inverse times the matrix for the right hand side. So that was in this way, Cramer's rule used determinants. And so if we look back in the book here, we have page, well, it depends on which book you're using, but Cramer's rule says that it says x1, but we'll use x and y. You take the determinant of the matrix A with the x column replaced with this, divided by the determinant of the original coefficient matrix, and the y value that's the solution is the matrix A with the y column, substituting that divided by the determinant of A. So we have 3 determinants we've got to determine, and our matrix A is so this is the matrix 3, 4, 5, 3. So it's 3, 4, 5, 3. And then we have this B matrix, which we don't actually use for Cramer's rule, but it's this, the right hand side. So let's find the determinant of A. And the way you do that is you just take the original matrix. Instead of using those square brackets, you do straight lines to designate that we're talking about taking the determinant. And in this case, it's just 3 times 3, which is 9, minus 4 times 5, which is 20. So that's equal to negative 11. Okay. Now, A sub x, what you do is you have the original coefficient matrix, but for the x column, which is the first column, you replace that with a negative 2, 4, and then the second column stays the same. So we do the determinant of that, so that'll be negative 2 times 3, which is negative 6, and then we subtract 4 times 4, which is 16, so that becomes negative 22, and the A sub y, we keep the first column the same as the original matrix, and we replace the second column with the values on the right hand side. So here we have 3 times 4, which is 12, and we subtract negative 2 times 5, which is negative 10, so that's positive 22. And if we come over here, then we can solve it. So A sub x is negative 22, A is negative 11, therefore x that satisfies these 2 equations is 2, and y is equal to A sub y, which is this number, 22, divided by A, which is negative 11, which gives me negative 2. And we can check the answer, so let's just plug it in there. So if we do the first equation, put in, for x we'll put in 2, and for y we'll put in -2. So we get 6 minus 8, which is -2, which is correct. And then the second one is 5 times 2 plus 3 times -2. So that's 10 minus 6, which is equal to 4, which is true. So we know that problem we did correctly. Okay, number 5. So similar kind of thing. So we have 3 equations and 3 unknowns. So our 3 equations are 4x minus y plus z equals -5, 2x plus 2y plus 3z equals 10, and 5x minus 2y plus 6z is equal to 1. So our A matrix is just 4, -1, 1, 2, 2, 3, 5, -2, 6. So it's the coefficients in front of each term. And our B matrix, this is the one we're going to substitute in, is that. So again, what we would have is that the the x solution is going to be a sub x divided by a. These are the values of the determinant. Y is equal to a sub y over a determinants, and z is equal to a sub z divided by a, the values for the determinants. So the determinant of a, here we have to use cofactors. So let's write out let's just write it out of here. 4, -1, 1, 2, 2, 3, 5, -2, 6. Okay. So we pick one row or column. I'm going to just pick the top one. There's no 0 so in there, so it's not advantageous to do one over another. So we take the coefficient 4. If we mark through this and this, we're left with that. Which, after you do this for a while, you get good at doing it without having to mark stuff out. So I'm going to mark it out, and then I'm going to take it off. So this marked out with that leaves these 4. Okay, then we have a subtraction, because it's this one. This goes plus, minus, plus, minus, plus, minus, plus, minus, plus. So we have negative and -1. When you mark that out and that, you got those 4 left. So you've got 2 and 3 and 5 and 6. And then plus that coefficient, which is 1. If you mark out this row and this column to go along with that number, you get 2, 2, 5, -2. 2, 2, 5, -2. Okay, so 4 times the determinant of that, well, that is going to be 12, 6 times 2, minus a -6. Okay, next one, you're going to have plus 1 because you've got a minus times a minus. You take 2 times 6, which is 12, minus 5 times 3, minus 15. And then the last one is plus 1 times 2 times -2, which is -4. And then we subtract 5 times 2, which is 10. So we've got 4 times 12 plus 6 is 18, plus 1 times -3, plus 1 times -14. And I'm just going to use my calculator for that last little bit. I could do it without a calculator, but I'm just letting you know you don't have to do everything in your head. Okay, 4 times 18 minus 3 minus 14. I get 55. Okay, so that's the determinant of A. That's the denominator in all those. So I'm going to next do A sub x. So what that is I'm going to replace the first column with the values in the B matrix, and then I'm going to leave everything else the same. So the last two columns stay the same. Again, I'm going to choose the first row. So we're going to have 5, negative 5. So negative 5. So cross that out, that leaves these 4. So it's 2, 3, negative 2, 6. Then I subtract, because I'm in this position, negative 1, that number. So you mark this out, you mark that out, you got these. So you got 10, 3, 1, 6. And then plus 1. It's plus because it's in plus minus plus. And we have the determinant. If you mark this out, mark that out, leaves these 4. So you get 10, 2, 1, negative 2. Okay, now we'll do the determinants. So you get negative 5, you get 12, 2 times 6, minus a negative 6. Okay, the next one is plus 1 times 10 times 6 is 60, minus 3 times 1, which is 3. And then you got plus 1 here. And 10 times negative 2 is negative 20. And then you subtract 2 times 1. So you get negative 5 times 18 plus 1 times 57 plus 1 times negative 22. And now we do the math. Negative 5 times 18 plus 57 minus 22. And I get negative 55, which is good because most of these solutions are probably whole numbers. So that is the determinant of this a sub x thing. Okay, now we're going to add. So we're going to do a sub y now. So again, we're going to take the original matrix, but we're going to substitute the B column matrix for the second column of the A. So we get that. That's the thing we did the determinant of. Again, I'm going to use this top row. So I got 4 times, well, let's show you. So 4 times the determinant of these 4, 10, 3, 1, 6. Then I have minus a negative 5. Cross this out, cross that out, that leaves these 4, so you get 2, 3, 5, 6. And then we got plus 1. From here, cross those out, you're left with 2, 10, 5, 1. 2, 10, 5, 1. Okay, so 4 times 60 minus 3. 10 times 6 is 60. Subtract 3 times 1. Then you have plus 5 times 12. 2 times 6. 5 times 3 is 15, so you subtract that. Plus 1 times 2 times 1, which is 2. And then you subtract 10 times 5, which is 50. So that's 4 times 57 plus 5 times negative 3 plus 1 times negative 48. 4 times 57 minus 3 times 5 plus minus 48. And I get 165, which is, again, a multiple of 55, so that makes me happy. Doesn't have to be that way, but in this book, it's probably the most likely scenario. And then we have a sub z. So the first two columns stay the same. And then we replace the last column. Choose the top row again. Again, it doesn't matter which row we choose. I'm just being consistent. Okay, so you take 4 times, so you mark this out, mark that out. That leaves 2, 10, negative 2, 1. Then you subtract negative 1 times, we'll cross this out and cross that out. You have 2, 10, 5, 1. 2, 10, 5, 1. Then you add negative 5. Cross that out and that out. That leaves 2, 2, 5, negative 2. So we have 4 times, 2 times 1 is 2. We subtract a negative 10. So negative 2 times 10 is negative 2 times 10. Actually, that's negative 20. So I look back on it. Negative 20. So 2 minus the negative 20. We have plus 1 from here, and you get 2 minus 50. 2 minus 50. And then finally, negative 5 times 2 times negative 2 is negative 4, and you subtract 2 times 5, which is 10. So we get 4 times 22. So 2 minus a negative 20 is the same as 2 plus 20. We get 1 times negative 48 minus 5 times negative 14. So a sub z is 4 times 22 minus 48 minus 5 times negative 14. And I get 110, which is a multiple of 55. So I'm happy still. So now we can come back over here and just put these things in here. So let's do e sub z was, so this was 110 divided by 55, which is 2. Make sure a is, let's do a. A was 55, positive 55, okay. A sub x is negative 55. So we get negative 55 over 55, and y is equal to, so a sub y was 165. So we get 165 over 55. So x equals negative 1, y equals 3. So there's your solution. Okay, next, 14. Use a determinant in the given vertices of a triangle to find the area of the triangle. Okay, so let's just write the vertices. Let's do x1, y1, x2, y2, x3, y3. So it doesn't matter which one you choose. And what number did I say this was? This was 14. Okay, so I'm just going to start at the top, 4, 5, and go clockwise. So 4, 5, 5, negative 2, and 0, 0. Well, that makes it a little easier, doesn't it? Okay, so those are the 3 points. And if you go back in the book, we look under areas, area of a triangle, and it says the area of a triangle equals plus or minus a half, and then you put in the coordinates like that. So the area is going to be equal to 1/2 the determinant of, so we just read all down here, 4, 5, 0 for x's. The y column is 5, -2, 0. And the last column is 1, 1, 1. So to make this easy, we just pick the column that has the most zeros in it. So we're going to use that one this time. So the only combination that's going to result in a non-zero coefficient is that one. So we're going to have the areas, and it's plus or minus. So I guess if we get a minus, we're going to make it plus. If it's a plus, we'll make it minus because the area has to be positive. So you've got plus or minus 1/2, and all we have to do is take this coefficient 1. Now, is it minus or plus? So you start up here, plus, minus, plus, minus, plus. So it's going to be positive. And when you mark these out, all you're left with is 4, 5, 5, -2. I must just drop the 1. And then you take the determinant, which is going to be 4 times -2, which is -8. So it's -8. And then you subtract 25. So 5 times 5 is 25. You subtract it. So that's -25 minus 8 is -33. -33 over 2. We're going to use the negative, so the actual area is 33 over 2. So let me just check that one out in the back of the book. I can't check it any other way. At least I don't know of any other way to check it. So this is section 8.5, number 14. That's the odd ones. (14) 33 over 2. That's it. Okay, next one is 27. It says area of the region. A large region of forest has been infested with gypsy moths. The region is roughly triangular, shown in the figure. From the northernmost vertex, just a second here. Okay, so what you have to do is you basically have to come up with a coordinate system. So what I'm going to do is I'm going to say, point A. I want to make that 0, 0. And then we can measure the other ones relative to it. It's only relative position. So if you look at B, it's going to be -25. If we have north as positive, -25, +10. Well, the other way around. So it's going to be +10 in the x direction, -25 in the y direction. And C is going to be +28 in the x direction and -20 in the y direction. So those are my 3 points. So I just do the same thing. A is equal to plus or minus, or it might be minus plus. Okay, so the x coordinates are 0, 10, 28. The y coordinates are 0, -25, -20. And then we put 1, 1, 1. So again, this calculation is going to be really easy because we're going to choose the top row as the one to use. So you get plus or minus a half times 1. This coefficient is going to be plus minus plus, so it'll be plus 1. And what we're left with is the determinant associated with those in the cofactor, which is 10 minus 25, 28 minus 20. And then the other ones are 0, so you don't have to worry about those. So plus or minus 1/2. And we get 10 times negative 20, which is negative 200. And then you've got minus for the other one, but you've got 28 times 25, which is 700, so it's negative 700. So you get plus or minus a half, and we've got negative 200 plus 700, so that's 500. So the area is going to be half of that, and we use the plus, so it's going to be 250 and miles squared, square miles. So it's going to be 250 square miles. Let's check that one out in the back of the book. 27, chapter 8, section 5, 27, 250 square miles. Okay. Next, 31. 2 more. We're getting there. Okay, so the next one is about whether points are collinear or not. And if you think about it, if you have points that are collinear, then the area would have to be 0. The only time that you would get a 0 area. So the determinant has to be 0 for this to work out. So again, we're going to calculate the area, but we'll use the area to answer that question. So again, you put the x values and the y values, and then you put 1, 1, 1. In this case, there's no easy way to get out of it, where they so I'm just going to choose the top row. So you get, the 1/2 really is your material, but I'll keep it in there. Plus minus a half. So you got you're going to have 2 times the matrix, determinant of what's left over once you cross out the rows, and you're going to have minus a negative 1/2. Okay. So we cross out this row, this column, we're left with negative 4, 1, 6, 1. Then we plus, the last number's 1, and we're left with these 4, negative 4, 4, 6, negative 3. So we have 2 times, so 4 times 1 is 4, subtract negative 3, and we get plus 1/2 times negative 4 minus 6. From that one, negative 4 minus 6 plus 1 times 12. Negative 4 times negative 3 is 12. Subtract 24. So that's 2 times 7 plus 1/2 times negative 10. Plus 1 times negative 12. So that's plus or minus 1/2. 14 minus 5 minus 12. So that's negative 17. So this is going to be negative. It's not going to be 0. So it does not equal 0. So that to me would indicate that they are not collinear. So we will check the back of the book and see what we get. So that's 8, 5, 31. Not collinear. Okay, so that's what you're looking for. You're looking for an area of 0. And the final problem is 39, which says use the determinant to find the equation of a line passing through these points. So 39 is negative 4, 3 and 2, 1. So the way you do that is, let's look in the book. 2 points form an equation of a line. Okay. So you make a determinant, and x, y, and 1 is the first row. Then you do the coordinates -4, 3, 1. The coordinates 2, 1, 1. And then you find the determinant. So I'm going to choose the top row. So you have x, I guess this is equal to 0. So you get x times the determinant that this then you have minus y. So you take that row, that column, you get these 4, negative 4, 1, 2, 1, and then plus 1. That's the 1, and then you use these 4. So you get negative 4, 3, 2, 1. So you'll get x times 3 minus 1 from this, 3 minus 1, negative y times negative 4 minus 2 plus 1 times negative 4 minus 6, negative 4 minus 6. So that's, you get 2x minus, well, you got negative 6, so negative 6, change sign, you get 6y, and then negative 10. Divide everything by 2, so you'll get x plus 3y minus 5. And I guess that's it. They didn't say what kind of form, whether they wanted slope intercept or some other form. So let's just see what they have in the book here. 8, 5 to 31. Eight, 5, not 31. It's 39. X plus 3y minus 5 equals 0. That's what I have. Okay. So again, what you do, you have x, y, and 1. The x coordinates, the y coordinates. Find the determinant, and there's your answer.